So we talked about a lot about matrices, and so the last few videos we talked about properties in matrices, how we can multiply matrices together, and find these things called determinants and inverses. And this video is going to show kind of how those concepts can be applied to systems of equations. So I'm going to go through two examples. One will be a 2 by 2 system of equation, two equations with two unknowns. And the second will be 3 equations with 3 unknowns. So let's start with this one. So let's say we want to solve this system of equation. There's a few different approaches that we've learned, substitution and elimination. Today we're going to talk about how to approach this with matrices. So the idea here is we can convert this into an equation where we're multiplying two matrices together. And the way it's going to work is like this. So we're just going to take the top row, 4 and 9, and then the bottom row, 8 and 3. And we're going to multiply this by a 1 by 2 matrix, x and y. And it's going to be equal to 18 over 6. Okay. I would encourage you guys right now to stop the video and see if you can work your way backwards to go from here to understand how this kind of works, how the multiplication works. So we multiply, this first row by this column, and then this second row by this column. And we actually end up with this equation over here on the left. Okay, so with that, the idea here is that we can solve this, we can treat this as an equation. We're going to call this matrix A, and I'm just going to use notation that is pretty common in different textbooks. This is A, this is X, and this is lowercase b. And so we can come up with the equation AX is equal to B, where A, X, and B are all matrices. And our goal here is to solve for X. Well, if we wanted to solve for X, know that we normally, if this is a normal equation, we would just divide by A. But we can't actually do that here because you can't divide matrices. Instead of dividing matrices, what we do is we multiply by the inverse. So what I'm going to do is multiply both sides by inverse A. And what that will do is it actually cancels out the original A over here on the left-hand side. So this actually goes away. And we're left with X is equal to inverse of A times B. Okay? And so so our goal here now is to find the inverse of A and then just multiply by B. Okay, so let's do that over here. The inverse of A, we know from previous videos, is 1 over the determinant of A times 3, negative 9, negative 8, and 4. Okay, let's find the determinant. That's going to be 12 minus positive 72, which is negative 1 over 60, not 16, 60. And so the inverse is defined as negative 1 over 60. Three, negative 9, negative 8, and 4. And we're actually let's just leave it like this. Okay? So we're going to leave it like this. It's just going to make the multiplication a little bit easier. We'll have to deal with less fractions. And so our answer, X, is going to be the inverse matrix, which we just found right here, times B, which is right here. Okay, so So let's take this first matrix here. And let's plug it into this equation. Okay, and now we're going to multiply this by b over here. Okay, so what we could do here is go through the multiplication, evaluate what we get. You can actually perform these operations using calculators. I haven't told you guys this yet because I want to teach you how to do it without a calculator. But if you go to your calculator, we're going to go to second, and then x to the negative 1, and then we're going to make a matrix. Okay, so our first matrix is a 2 by 2, and I'm going to plug in the coordinate points here, or the elements. So 3, negative 9, negative 8, and then 4. Okay, go to quit. I'm going to go back to the matrix page, and I'm going to enter in a matrix for matrix B, or enter elements for matrix B. So this has 2 rows and 1 column. I think I said it was a 1 by 2 before. It's actually a 2 by 1. Sorry. This is 18 and then 2. Sorry, 18 and 6. Okay, so now I'm going to go back and we're going to type this equation right here in. So this is we call this matrix A, and this was matrix B in our calculator. So this is negative 160, 1/60th times, go to second and then matrix, and I'm going to type in matrix A, and then multiply it by matrix B. The one thing I will say here is, I don't know if you guys can see my cursor, make sure you have multiplication signs right here. I don't think it works if you don't have the multiplication signs. Okay, and so we get 0 and 2, which is a matrix. So over here, we get 0 over 2. So 0 and 2. Well, that is actually our x value and our y value. So the solution for the systems of equation is 0 for x and then 2 for y. Okay, let's do this again with the 3 by 3 matrix. Okay, let's do a 3 by 3 matrix. So example 2. So let's say we have the following matrix, or the following system of equations. We'll get to the 3 by 3 matrix in a second. So 2x minus 3y minus z equals 3. Negative 4x minus y plus z equals 23. Then x plus 4y plus 5z equals negative 26. Okay, so the first thing we're going to do, like we did in the last video, is convert this to a matrix. So I'm going to take the top row, middle row, and then the bottom row. Okay, so 3 by 3 matrix here, and we're going to multiply this by the following matrix, 3 by 1. And that's going to be equal to this last column here. Okay. So this is going to be, we'll call this A. This is our X, that's the matrix we want to solve for, and this is B. So like we did before, we're going to turn this into an equation, and we're going to multiply by the inverse of A on both sides. Works even though it's a 3 by 3 matrix, like this, and that will cancel out the a's over here, and we're left with the following equation, which we're going to use to solve for our three variables. Sorry for using the same variable here. I'm just trying to be consistent with some textbooks. But just recognize x here is a matrix. It's not just individual x. So x is a matrix. Okay, so the hard part about this is going to be a couple things. Let's start by finding the determinant of A, because ultimately we want to find the inverse. And to find the inverse, we need to find the determinant. So I'll write that over here. So let's start there. Well, didn't tell you this before, but you can actually find the determinant on your calculator. So the first thing I'm going to do here is let's go to matrix. Let's change this to a 3 by 3, and I'm going to enter in our original matrix here. So this becomes 2, -3, -1, -4, -1, +1, 1, 4, 5. Okay, we're going to call this matrix A. Okay, so let's go to the matrix page, and I'm going to go to math, and then calculate the determinant. Let me go back here. Matrix page, go to math, calculate the determinant of matrix A. So I'm going to be using this matrix. So -66. Remember from the inverse videos, the inverse of a 3 by 3 matrix, you have to find the determinant first, and it's quite a few steps. So I think that I'm just trying to save a little bit of time by using the functions that are available on the calculator. Okay, next this is the hard part, is using this big matrix here. So what we're going to do is, I'll try to go through this quickly because we already went through this in a previous video. We're going to cancel out the first row and the first column and use the following determinant right here to identify the element in this spot right here. Okay, so let me go through each of these. First row, second column. Cancel those out. We get -4, 1, 1, 5. First row, third column. -4, -1, 1, 4. First row, or second row, first column. -3, -1, 4, 5. Middle, 2, -1, 1, 5. 2, -3, 1, 4. We're canceling out the first column, third row. So we're left with -3, -1, -1, 1. 2, -1, -4, 1. And then lastly, third row, third column. Cancel those out. We're left with 2, -3, -4, and -1. Okay? So now we make the signs. Remember, they alternate. And now let's go from here to our 3 by 3 matrix. Okay. So -5 minus 4, that's -9. This is -20 minus 1 with a negative in the front, so it's +21. Okay, -16 plus 1, which is -15. This is -15. I hate doing this. This is a 4. It looks kind of like an 8. This is 11. This is also 11. 8 minus, is this 11 again? Yes, -11. Okay. So now, this is -4. 2, this is 2. If you want to use a calculator here to help you with this arithmetic, feel free to do that. This is -14. Okay. Hopefully that's right. So now we do this. We keep the kind of the diagonal the same, and we're going to flip the location of the numbers. So -9, 21 and the 11 will switch. The -4 and the -15 are going to switch. So 21, 11, -11. This is -15, -2, -11, and this is -14. Okay? And so this isn't the inverse, it's almost the inverse. The inverse is defined as 1 over the determinant of A times this. Okay, so let's plug in the determinant, which we used our calculator to find. Okay, so instead of 1 determinant, it's a -1 over 66, -9, 11, -4, 21, 11, 2, -15, -11, -14. Okay, we are almost done, I promise. All right, so the answer is going to be defined as the inverse matrix times B. So here's our inverse matrix. Like I said before, we're just going to leave the 1 over the determinant alone on the outside. Multiply by this transformed matrix. And then we're going to multiply it by our original 3 by 1 over here. So 321, -26. 323, -26. Okay, let's not do that by hand. Let's use a calculator. So what we need to do here is, let's go to the matrix. I'm going to plug in our 3 by 1 here for B. So it's 3 by 1 now. So 3, 23, -26. Okay, and now let's go back and let's plug in our new matrix here for C. Because we're not using the original A, we're using kind of that transformed one. So C, we're going to go down and go to edit for letter C. Okay, 3 by 3. So this is -9, 11, -4, 21, 11, 2, -15, -11, -14. Okay, so now we're going to go back to the screen here. And so our answer is going to be -1 over 66, which is 1 over the determinant, times the matrix C times the matrix B. Okay, and here's our answer. So -5, -4, and -1. And so the answer here is -5, -4, -1. And the way we can write this is equivalent to x, y, and z. Okay? So x, y, and z, the solution to this system of equations, the intersection point in 3 dimensions between these three-dimensional lines is this coordinate point right here. Okay, and that's the answer for this one. I think a reasonable question that you guys might have in the back of your mind is, why are we doing this? When you can just solve this using kind of those conventional techniques that you learned in Algebra 1. 2 reasons. One is matrices have other applications, but the main reason here is once you start to go into higher dimensions, let's say we have a 4 by 4 or a 5 by 5 or a 100 by 100 system of equation. We don't actually use kind of these conventional methods anymore. We use programs on the computer to calculate what those are, and those programs use this math right here to do that. So people program the mathematics into like a programming language, and that will help you solve higher dimension system of equations. Okay, so with that, for the remainder of class, I want you guys to go through problem set 1 here. The answer key is right below with all the work. And then once you're finished with problem set 1, go on to problem set 2.